All right. Sometimes you have examples of situations in like where you might be trying to figure out the limit of a function at a certain number, x approaching a certain number, and it turns out that it just doesn't exist. Okay, sometimes the limit doesn't exist. Sometimes the output values of the function just aren't approaching any particular number. They might be bouncing around, or there might be a jump or a gap, or like it might be approaching infinity, so you can't put a number on it. So we're going to look at the next few videos, we're going to look at some examples of how that can happen, how you might end up with a limit that doesn't exist. So the first is going to be different left and right limits. So let's look for our example here at kind of a funny, weird function. Let's look at the absolute value of x divided by x. We don't deal with absolute values that often because they can be kind of weird, but this is a great example right here. So if we try to interpret this function, it breaks down into two cases, like absolute value always does, right? Because the behavior of absolute value depends on whether the input is positive or negative. In this situation, by the way, note that x can't be 0, otherwise we'll have that 0 divided by 0 sort of situation. So we're just going to look at the cases where x is negative and where x is positive. So first, if x is negative, less than 0, then the absolute value of x will be defined as its opposite. Okay, it'll be negative x. This is weird, trippy perhaps, but if x is negative, absolute value will give you negative x, which is the negative number, which will be a positive number, right? So this negative here is to ensure that the output does end up being positive, since x was already negative. All right, so that means that the absolute value of x divided by x will just be negative x over x, which simplifies to negative 1. It's just negative 1. What about in the positive case? If x is positive, well, then the absolute value of x just equals itself, right? The absolute value of a positive number is just itself. So then when I take this function, I get x over x, which is just positive 1. So this is just going to be positive 1 on one side and negative 1 on the other side. Let's draw a graph. All right, so on one side, we're going to have, on the right-hand side, we're going to have positive 1, and the left-hand side, we're going to have negative 1. Now, we said it's not defined at 0, right? Because that would be division by 0. So when these lines meet the y-axis, they're going to meet at an open circle like this to indicate that there's no defined value at 0. But we're coming all the way up to, but just not touching the y-axis on both sides. So now the question would be, what is the limit as x approaches 0 of this function? The answer is that it doesn't exist. Not because the function's undefined, but because what you're approaching from the left and what you're approaching from the right, and by what I mean what y coordinate, like what height, the height you're approaching from the left and the height you're approaching from the right are not the same. That's the reason that this doesn't exist. The open circle is not a problem. Like what's actually happening at 0 is totally irrelevant and doesn't have any bearing on the actual limit value. What's happening as you approach 0 is what matters. And so what we can do here is break this down into a limit from the left and a limit from the right. So I'm going to introduce some new notation that we can use for what are called one-sided limits, or one-handed limits or something. So limit from the left, that means let's just look at what happens if we approach x from the left side. Meaning slightly smaller numbers. And the notation for that is limit as x approaches 0, 0 in particular, but in some other problem you could use a different number. But then you put a little negative superscript. Superscript is like an exponent, like just raised up a little bit. So you put a superscript negative sign, and that means that you're approaching from the left only. So for this function, that limit, that one-sided limit does exist, because as you come in from the left, right, as x is approaching 0 from the left-hand side, these points here, their y-coordinates are all equal to negative 1. And so what are we approaching? Negative 1, right? The limit from the left, from the right, we just did from the left, is denoted with, instead of a little superscript minus, you use a little superscript plus after the number. And for this function, on the right-hand side, as we come in, the points are up here with y-coordinate +1, and so the y-coordinate is approaching +1. I mean, it's constant. It's staying constant, so it's approaching itself, basically. So we have these two one-sided limits from the left and right, which do exist, but they're just not equal to each other. And that means that the overall limit, without putting a plus or a minus here, this means the overall limit. It's sometimes called a two-sided limit. And if it's not specified, we always assume we're talking about a two-sided limit. That one doesn't exist. So that's one way that you can have a limit not exist, when the left and right limits don't agree with each other.